Hey everyone, welcome back to the channel. My name is Patrick and you're watching The Everyday Machinist. If you like this kind of content, please subscribe to my channel, like, comment, share the videos. It really helps grow the channel. I really appreciate it. I like seeing that stuff and I like teaching you guys and bringing you guys in and showing you what I do here on a daily basis. So with that being said, you're going to see about a 40-minute long section, I apologize, of me bringing you into the computer, into the CAD cam space, and giving some of my thoughts, opinions on how I approach a part and how I look at specific things, and generally some kind of tips and tricks and some things that I think are real valuable when just trying to get one or two parts done. So hopefully you pick up on some of that stuff that I'm trying to put down. Some of the stuff a little opinionated, but it's kind of difficult narrating a video like that because you're thinking of a lot of other things and you're just trying to convey or get the point across on pretty much what you're trying to explain, what you're trying to sell, you know? So hope you appreciate it. Hope you like it. Right after that, at the end of the video, after that part of the video, you're going to come back and I'll talk about a few other things, some exciting things. And again, this is part of the build series, right? So this kind of gets you into the mindset of where I'm coming from when we start these build series videos, because this is how basically they're all going to start. So when you see that part where I bring you in onto the screen capture, you're going to see me kind of going through a couple things, and every build video is going to kind of start that way. I'm going to bring you into the CAD cam space, and then we're going to walk right through it. I wanted to get a couple things rolled out, but I wanted to or have some videos of actual build stuff. I do apologize again for that, but I wanted to get a couple things in check before I start putting them out. And I think having a video out there where you kind of see where I'm coming from or starting from should help you guys understand my thought process of moving through the job. So yeah, give it a watch. Sorry again, a little long form, but hopefully you guys enjoy it. And right after that, we're going to come back here and I'll talk to you guys about some new things we're doing and what's coming down the road. So okay, so we're over here on the computer and I have Fusion 360 pulled up. Fusion 360 happens just to be my primary program or software that I choose to use. I've used SolidWorks, SolidCam, Mastercam. They all pretty much do the same thing. Fusion is very basic and simple. They are getting a lot better at their programming for CAD and CAM, especially CAM. I just choose to use it. There's no benefit to it whatsoever. All those programs have their issues anyway. But anyway, so here we're going to discuss 3 different parts and how I'm going to actually model them into the CAD space to incorporate the vise and everything else that we need to eventually get over to the CAM space and get some tool paths on it and start making chips. So here we have one Curt 6-inch vise, very generic vise, and I believe Fusion has it in their library. So if you have Fusion 360, it should be there. Fusion also has their tables. So right now we actually have the VF5 here, the table. We're going to be working on the VF5. And the VF5 actually has all vices on there, and you'll see they are shifted. I did omit them just to have we're only working with one vise, just to have it there center on the table for visual purposes. It just makes it easier to follow along. So every one of my machines have a table and a vise. However they're orientated, they are modeled. So the VF5 has 4, the VF3 has, I believe, 4 as well. The VF2 currently doesn't have any, but I would put 2 on them. So there are different variants and versions that I have saved in specific folders for whatever machine I'm working on. And of course, I can model them as I go. So as they're stored, so we have right here, VF5 4 vise, okay, version 10, because I've modified them here and there. But there's other ones, VF2, VF3, not that there's a vise on there, but if there's any type of chuck or any version of that for the lathe, then it's going to be in my in that folder as well for under my work holding or vise fixturing. So we have them there. Now let's go. So the origin, you're going to look here at the origin. This is actually for the vices themselves. The other origin, I believe, is the same actually. So the overall version of this, or the file for this, for build 1, you're going to have an origin there as well. So they actually are the same for that vise. or they're in their same location, and the vise has its origin there. Now, if you see all of these other vices, there's one origin here, obviously, for this specific file here, program model. I just have it on the one, and because primarily I utilized the G54, the first vise here, so it's going to have the origin right there. Now, the origin really comes into play in the cam space, and I'll show you that when we get to that point. Oh, and sometimes too, like if I'm running a big part, and you can see all these vices are pretty much the same here with their 100 thou by 100 thou step. Now, when I pull this up into the CAD space or into whatever part I'm working on, when I bring that in, it's going to look just like this. The vices are going to look like this, and they're going to be located on the table approximately where they need to be, but the spacing as well. And then in the program, the vices, or in the mill machine, the vices are going to have their G54, 55, 56, and 57 as well in the same location. Everything that is modeled is in the exact location that it needs to be prior to starting a project for that specific machine. So we have to keep that in mind. We want everything to be exactly where it is in the machine. So there's no issues, there's no mistaking where something is. And it helps because, especially if you make an error on some type of tool path, you know it's there. So again, for the reliability, consistency, repeatability, all that stuff has to be there. So we really want everything in the CAD space from the get-go. So we're going to deselect them. We're going to get rid of that. We'll close this down. Like I was explaining too before, we'll get into this, why this is. This is actually 1 inch off that surface from the back corner. And again, this is our X for our cam space here. We have our Y and our X0. So this back surface and this back surface here. That corner is our XY0. And 1 inch above this surface is our Z0. And again, jumping a little forward here, but even though the VF5 has probing, I typically do not use it for my day-to-day operation for touching off my Z or my tooling. Everything is still done with that SPI 1 inch height indicator for touching off my tooling. It's a habit. My other machines are older, and again, it just gives me that generic habit or muscle memory of doing that, and I know it's exactly where it needs to be. Not that any of it would be different if I was still using probing or touching off the tooling with the tool probe. I prefer doing this way. It really doesn't matter, but you can still actually tell the program where it is for a reference point for yourself if you continue or you utilize tool probing. So again, our vise is sitting here, and we have it as a standard. These are actually the 2 inch tall by 3/4, and we have 100 thou by 100 thou step in both of them. And they are spaced appropriately away here to a known value where it is shimmed, or the shouldered socket cap screw bolts from McMaster are protrude enough to leave a gap between these two faces. And that value is 660 thou on my machine. So when I want to face off jaws, I turn the dynamic part of the jaw all the way in, pushing both jaws all the way together, and usually the heads of the bolts for the McMaster car socket cap screw shoulder bolts are touching. And generally is where it needs to be. The more important value for this, or what's most critical, is this first jaw here on the static part of the jaw. Because this spacing from this face to this face here is critical. It has to be the same in the machine or to your work coordinate offset or coordinate system here. It has to be the same. Sometimes, like if this isn't all the way in or whatever the case may be, it really doesn't matter except the depth of it, except the height here. Like they have to be the same, obviously, for consistency. So we need to keep that in mind. So this is how they start off when I bring them in. Now, I'll have a part, right? So let's say we have a part here, and I'll get into these parts and their meanings and what we're going to utilize, what we're going to do with them. I have this part here. I'll bring the part in. I'll get it from a CAD model. I'll have to draw it up or get it as a step file from somebody. And then I'll bring in the jaw. I'll bring in any other tooling that I need into this specific part. I'm not bringing this specific part into my vise setup, because then I compromise that vise setup. Now there's a bunch of junk in that file and I don't want to save it. I want it to be universal. So when you have a part, you then bring in, import into drawing, you bring in your vices to that specific part. And again, they vary, so that's something to consider. Again, a lot of this is around Fusion 360. I apologize if you don't have that, or this might be a little confusing. But generally, hopefully you take away from that the idea that I'm trying to inform everybody on is the basic concept of repeatability and reliability, and just being consistent. That's, I think, first and foremost, is the biggest thing. It's just being consistent. So we got the basics down. Here's our basic setup. Here's what we're going to use, G54. We're just going to use one vise for this particular purpose. We have 3 parts in here. One is going to be my interpretation on holding a thin part. Okay, there's a part similar that I've done like this. I think there's actually a floor to this pocket. Doesn't make any difference. And I think overall, this is 60 thou. I think it was thinner, but still what I'm going to show everybody, same rules apply. We also have a part here. This is a shoot handle. I think we're going to start out with that, and you guys also saw that part there. Every single part has a purpose, and I'm going to go through them as quick as I can. I'm going to drag this video out. So here we have the shoot handle. I'm going to get rid of this. Here we have the shoot handle, and we're going to put stock around it. I believe this shoot handle is 3/8 of an inch thick, the final thickness on this part. Correct. So what we're going to do is we're going to draw a sketch so we can start simulating our stock. Now everything must be simulated. Stock, everything, you're going to label it stock or give it a value, give it a number. I think we'll do 9 inches wide, 3 inches tall, and then we'll set the depth in a second. But we'll just generally get this in an area where it looks pretty even and consistent. Okay. I think I can press pull the stock. We're going to do a new component, 2 sides. I think we could pull this down so it's going to kind of cover up the whole thing. So we're going to use 1/2 inch stock. So our Z negative value is 400 thou. So we're covering the part. Our Z positive value is going to be 25 thou. Okay, so that's giving us 100. Hold on a second. Should give us an even amount of space around that. See, did I do this right? No. So we just have to add. That's right. 4. That's right. So, sorry if I'm a little behind. Been a long day already. So now we have our stock. And our stock is, let's do this, part 1 stock. Okay, so our stock should be 100 thou below the surface, which is convenient because our step is 100 thou. Our step in our vise draws here is 100 thou. So it is pretty convenient. So now we have our stock. Now these 2 parts are enjoined. Okay, they're both components. Okay, so now what we're going to do is we're going to place it in here. Pretty straightforward, pretty simple. Now I'm not going to go too crazy on specifically for this op1, and I'll explain that real quick. But what we're going to do is we're going to go in to our vise. Right now we do not need any of our dynamic or jaw bolts for that. This is typically what I do. I know it's there. I know it's been machined, so I'm not too concerned about it. So we have our shoot handle. We're going to grab both of these and we are going to move them. We're going to grab the bottom corner right there and we're going to snap, point it right to there. Don't worry about the overhang. Most cases I would slide it over. It doesn't really matter at this point. Or I would center it because the stock is strong enough. So right there. Actually, we'll just go ahead and do it. Just make it easy. Nothing is working in my favorite today. Okay, pretty generic right there. Now, obviously you'd have to check the distance from here to here. Now, why you could do that, you could generally do it if you have enough stock. And again, you're going off the raw stock. If this is just one part, this is typically how I would do it. If it was multiple parts, there would either be a backstop. I do not use, or rest stop, or a part stop, raw stock stop. I don't use one. Never have. This is really getting into the weeds, but what I typically do is I'll either take a measurement, because this part isn't big enough to fit between two vices, and I wouldn't necessarily run it long ways with the vise. Just something I wouldn't do. It's too unsupported, too much of a risk there. Typically, I would just run it out on something. Now, I've done part stops before. I'm not saying you can't do it. I typically don't do it. There's other things I could do, but if it's a couple parts, I'm just going to run a micrometer off, a caliper off of it, and then measure the raw stock, and then it'll tell me what that value is just by obviously taking a quick measurement here in Fusion 360. So 1.5 inches. It's pretty simple. This being 9 inches, this being 6-inch jaw, 9-inch stock. Pretty generic. So we have that there. Now we're going to run in our manufacturing space. We'll jump over that real quick. We'll just do it for this part. Simple setup. So this is where it defaults. We need to define our part. Looks like I was on the lathe before. I don't know why Fusion does that. It's kind of annoying. I think there's a setting for it, but start by clicking on the model, and now we want to move our origin, because right there, obviously, that's the origin. Quick way to crash your machine. The selected point, it snaps right to that. There's my X, there's my Y, there's my Z. Stock. You can either enter it in, or I believe Fusion has a way. I don't want to get too crazy with this because you may not have Fusion. So we're just going to leave it there. Primarily, I don't use it. There's not going to be a crazy adaptive program on here. Now, what you can do, obviously, is go back into, after highlighting, and I wish you could do it before, but we'll go in and we'll just select it. It's there, because it's just kind of a pain. You have to go back out, deselect it, go back in. So we have our stock, we have everything modeled. You're supposed to, again. My methods are slightly different. Now, there's really no limit to this because you're not going to be stepping down or have to flip the part halfway for this specific circumstance. What I would normally do is just machine down the whole contour here. I actually will not adapt it. It's too much of a waste of time to get rid of all this material, and there's no reason. And a lot of the other material adds support. So in most cases, I'll just ramp down the contour of this part. And it's pretty straightforward. We have 5. Pick a 3/16 tool. And now, let's just say And what I usually will do is go down about 25 thou below that. And stock top is fine. Multiple depths. And what I'll do is I'll get rid of lead in, lead out, and I'll do ramp. Sorry if I'm going fast, it's just kind of second nature for me. We're going to do stock to leave. We can just leave it that way, that's fine. Nothing. It's working. Sorry, it was in the way of my screen record there. So here we have it. I'll just ramp down, stock to leave. Nothing is working the way I want it today. Let's have everything modeled. So as you can see now, everything is there. We have our simulated tool holder with our tool. And again, it has to be the correct stick out. So just keep that in mind. So I'm actually ramping down this part. This one says about 3 minutes, just a little under. You can go faster, just change the, it doesn't need to have all of this. Actually it is, plunge and ramp, 45, that's perfect. So we have that, you know, obviously that's not gonna be the first program, but you get the general idea of what I'm getting at. I'm not gonna adaptive all that wasted material, it's not worth it. Again, if I'm only doing a couple parts, that's fine. It doesn't really matter. You can if you have a different way about it. But if I adapt it out, get rid of all the material, if I run this contour down low enough to where either I can put it in the bandsaw to trim the material off, I'm going to. And that's just me. You can obviously do your pockets first, drill your holes first, ramp down. Right now we have 75 thou worth of material still left holding this part on, which is plenty. Holding that part to that area and everything surrounding it. You know, and again, there's a couple things you can do. I'm not saying don't adaptive down it. I typically won't. So it's just a massive waste of time to run the machine. In some circumstances, like the starting point, you know, when I go to do the finish contour, you know, it'll start outside the stock. So it gives me a way to get in and kind of trim things out of the way. I might even just trim out with the raw stock. I might run the bandsaw in this way and in this way into the channel cut in by the end mill and just cut in or just kind of generally take out some of the material. May sound silly. It's just something that I do on some of these, you know, 1 to 5 parts. It's a whole lot faster than trying to adaptive all that stuff out. May not take that much time. But again, in my opinion, it might leave a little more stability to it. So there's that. And we obviously we're leaving stock on the first operation, on the first contour, so we don't get, we're not recutting chips and make the surface look like you know, hit it with a glass beater or a hand file. So plenty of coolant, plenty of all that stuff there. When we're done with that, you know, there's going to be multiple setups, you know, multiple things I'm going to do. I might have a different, it's crazy. I might have another vise sitting in here, okay? But I'm still going to call it, or it's G55. Sometimes I'll even, if it's 1 or 2 parts that are, you know, crazy or critical, I'll do this and cut this jaw like we're about to do to fit this part. So now the raw stock is no longer relevant. So, and again, sorry, this is how this was modeled. So to do all this, of course. Sorry, folks, being difficult. Hurts me. When I want to cut this part out, what I'm going to do, again, may sound silly, but there's really no other effective way to hold it. And the reason why I'm doing this, I don't even care if it runs out past the right here. I don't care if it runs out past that. As long as there's enough in there to hold that part. And the other side of the vise, or the other part of the jaw, is going to reflect that as well. This may seem silly to you. I completely understand. However, it's just something I prefer. And the only reason I say that, so we're going to try to do this so that it, you might want to, orient the part so that it can grab as much as the soft draw as possible. Let's just keep it simple. So let's take that for example. Not exactly where I'd want it, but just keep an open mind. I'm going to then mill these vise draws to then incorporate this part in it. Okay, and only you have to stick it down. I might go a little bit deeper to get past the chamfer that we put on there. So I might only stick it down maybe 150 thou, over 1/8 of an inch down. The reason I do that is if I have chamfers on this side, or I have counterbores on this side, I don't want to guess. I could part probe. Not everybody has a part probe. I don't want to. It's just too much of a headache for me to do it for one part, or 2 parts, or 5 parts. It's a lot easier to do it this way. So now, if I stick with my model, I have my work coordinate offset already done right here. Obviously, we moved the part, but I have it done right there. I'm in this space as well. Okay, new setup. What I'm going to do is actually model as if it was a part these vise draws. So that second setup, or would be the first setup, is me actually going through whatever the process I'm doing of me actually cutting these soft draws. And it's done inside of this program. Exactly for this part. Okay? So hopefully you guys get that, understand my thinking of it. There are a couple other things involved with it, but I'm going to be here all day. It's going to be a freaking marathon video if I keep going. So hopefully you guys understand that. And as I make more build videos, I'm going to be incorporating this stuff in there, part of the build series of me actually doing this. But I wanted to start off with a basic premise of my mindset and how I might approach a part like this. This part, let's get rid of this. This part is the same thing. It might seem basic. Let's discount these holes. Okay, let's say they're not there. You might think it's a pretty basic part. Okay, you might face it off in the bottom, but then if you face it off in the bottom to start, how do you get the full part with those radiuses on there? So it's kind of something to consider when it comes to that. What most likely I would do, again, let's get the most meat of the part right on there. This is somewhat of a hypothetical, but just again, keep an open mind. I'm going to cut these vise draws to fit this profile. Now, obviously, this jaw is going to be back here. Okay. But I'm going to cut these vise draws to fit it. Even if I had 100 parts. Now, in this circumstance, it's a lot easier. In this circumstance, I'm going to pick stock that's very close. Not like our shoot handle here, where I'm going to have so much excess material. Of course, there is that consideration that I could do that. It depends on the part. But really the focus was that I'm going to orient this part right here in a way where I can get most of the meat on this, and it's going to sit inside the soft jaws, and it's going to be to the model, to my work coordinate offset, so that when it goes into the machine, there is no mistake. The machine in this exact CAD CAM space cut the soft jaw So theoretically, this part should drop into the soft jaw. Pretty basic. Hope that makes sense out of all this talking I'm doing. So here, again, no different. As basic as a part it is. Now we could talk about doing those holes, not necessarily cutting the soft jaw. Let's say you stand this part up. Not necessarily saying I'm going to cut the soft jaw to have those double radiuses. But what I would do, obviously it's not going to stick up that far. What you could do if you had a lot of these parts to do, well, let's say you had a couple. Now, let me try to explain this as best I can. Regardless of where this is, okay, what I'm going to do, I'm going to align this part. This is a quick way. Let's say you had one to do, okay? You don't really care. Let's say it's sitting on the bottom, or there is a broader step on this jaw, okay? It's got enough meat hanging into the jaws to hold it, but it's right there. Let's say you're not too sure about setting it in for the X0 so they're the same, okay? What you could do is, in the model, these two surfaces are the same depth, so they're in line. However, you do that in the model so that this face is the X0. Now keep in mind, you need to make sure you know where the Y0 is, but if this face is X0, as long as it's in the model, aligned with your X, you're keeping it there. You're keeping your work coordinate system here, 1 inch above on the back left corner for X and Y. In the model, this part is in line with the X, but let's say in the machine, it's actually sitting in the vise in the middle. That's fine. However, you then pick this surface again and tell the machine that your G54, whatever your work coordinate offset system is, this face is now, whatever it is going to be X0. I hope you understand that, but that's how I would do it. In the model, it's not. In the model, this part is going to be in line with your X0. In the machine, you can put whatever you want in X as long as you tell it that this face now in the machine is X0. Always keep it consistent in the program here. Doesn't matter where it is, technically doesn't matter where it is, as long as everything else lines up. I hope you kind of understand that. Again, I'm going to show a little bit more of that as I go with some of these parts we're going to be making in the build series. We'll get into that and I'll show you guys that. So now this last part here hopefully isn't as confusing as the other stuff. Hopefully you're not confused. How do you make a really thin part in a standard vise? You're not super gluing it down. You're not doing the tape and super glue method. You're not vacuum tabling it. You're not, hot gluing it, whatever the case may be. You're not doing that stuff. My approach to something like this, if we have raw stock, so we're going to draw a raw stock real quick. Let's see, 5 by, I don't know exactly how big this part is, 1.25. Yeah, pretty center, nothing too crazy. Okay. Now what I'm going to do, I'm not going to extend the stock in any direction that would be confusing. So now what we have here is we have okay, the red is our stock, okay? The gray is our part. Let's bring it over to the vise. We're actually going to start off with the reverse side here. Now don't worry about it how it's sitting in the vise right now. What I want to do is explain. Let's get the color here. Too confusing. Gold is now our stock. What I want to explain is let's get this draw in place. Doesn't have to be perfect, instructional purposes only. Let's get rid of the table, it's annoying. Imagine this yellow part of the stock is one solid piece. It starts out as one big solid piece of aluminum, and then there's our part. If you were to machine this, ideally, what is going to happen if this were me, I would actually try to get this to be a little bit better. Let's do this. Sorry, folks. Just do this. Okay. Imagine what we're doing here. To hold this part, and I hope you can follow along. The majority of this stock on the ends is going to stay fixed to the part. These sides here, not so much. So imagine we have that. You're gonna machine down. You're gonna do all the work. You're gonna do the pocket in here, okay? You're gonna design it pretty much like this. You're gonna leave these two nuggets on the end here, okay? And by the time you go to flip it, they're gonna be the same depth from this surface to this surface. They're gonna be equal on both sides. In doing so, now the reason I had to come across this because these were so thin, this part was so thin here and so wide with not a lot of support, I couldn't just clamp onto it. I needed something else. And that's where these two nuggets kind of came into play, is having them on there so that we're able to clamp onto the part without it moving or vibrating or chattering or anything else like that. Now you're gonna have stock underneath it as well. So there's a couple ways to approach this. You could prep the raw stock, obviously. You're going to face it top and bottom so it's consistent, right? And then you're going to do the sides. Okay, you're going to give yourself a very clean machined raw stock part. This way you can then rotate this whole thing with still leaving these nuggets on as you're doing the whole part. You could even attempt to get into these radius corners and still have plenty of material holding that part together. Okay, that's just something to consider. And again, I'll get a little bit more in depth with that. I might just make a part just to show actually how that's being done. But this is going to be for that. This is what I would typically use for a thin part like this in some fashion. So hopefully this helps most people realize on holding a kind of semi-difficult part. And that's what it's going to look like. Get a better reality. So if the part is almost done, that's basically what it's going to look like. You're going to have this being held on for those ends. So the option there is you could offline trim the majority of the stock away and then only leave so much on there. Or you can trim it down. You can machine down this surface when you're ready to do that. You can do it on both ends, on both sides, and get it down to where it's a little bit easier to deal with. So you're kind of you're kind of windowing the part, as you're making it. You're just leaving the majority of the raw stock on the end, so you're not crushing it inside the vise. So I hope everybody kind of understood that. It's kind of hard doing these videos sometimes, so you don't want to force something, or you're worried that it's not going to come across as you hoped. But hopefully you guys understand what I was getting at here, and to look at some three examples of what I would utilize on holding a couple different parts. So this being one of them, kind of a difficult part to hold. You don't have to have this exact vise draw. It could be something completely different. So keep that in mind. You can make one whatever you want, something thicker, something bigger. There's no limitation to that. If you had a bunch of these to do, make a bunch. If you only have one vise, try to fit them in there. But keep that in mind as I went through, especially in this part. You don't have to, if you have like 4 of these in a row, take that for example, right? If we have 4 of these in a row, say 3, don't worry about any of that. I'm not going to adapt any of this stuff. I'm just going to run a ramping contour down, leaving stock so that I can come back and do a finish pass, then flip it over or cut them out individually. Again, there's so many different ways to do that, but I think the biggest thing is utilizing these soft draws in that way. If you're doing 1 or 2 parts, to then hold them for that last operation. And again, the biggest takeaway on this is that we're doing that in the cam space or CAD space, cam space, so that we don't have to try to indicate that part in. Tell me how I'm going to get this shoot handle in there and it's going to be dead perfect, or I'm going to waste so much time doing it. I'm not. This might not be the best example. This might be a better example because it's a little more basic of a shape for you guys to understand, but keep that in mind. That's what it's going to be. You want to model it, and even if, real quick, even if I did do it this way, okay? I don't want to have to guess if I'm doing a bunch of these parts. This is all I need. Go back a little bit. Right? So let's look at this for example. This is all I need. Right? These little corners. Take it a step further. Let's say I put it in there. Right? I just need one jaw. I don't need the other jaw to have the same radius going into it. It just has to be the same height. So this jaw only has to be flat, because the radius on that part, sorry about that guys, the radius on the part is what's going to indicate the part into the vise draw. That's the biggest thing. So hopefully you guys understand that. Sorry, this might be a little long form. But again, hopefully you guys understand what I'm getting at. If you just want to be able to run through these parts, this is all you need. This radius right here, if it was cut into the jaw, obviously it's not, is your location. So in the model, in your cam space, it is around your work coordinate offset. It's where it needs to be. Then you run a program to cut your soft jaws to then hold that part. So hopefully that helps, and we'll get ready to wrap up this video. All right, we're back. Sorry if that was really long, but more importantly, hopefully you guys learned something or see where I'm coming from. So that's, again, it's going to help start our build series. This is technically the first video for our build series. So hopefully that gives you an idea where I'm coming from and where the videos are going to go from there. But with, obviously, we're going to be making chips incorporated with those, videos. So you'll have both CAD CAM and making chips and having a done part. So that's the goal anyway. The hard part is keeping it, relatively within like a 20 to 25 minute video, maybe 30-minute video, whatever's comfortable for people. I'd like to keep it in that area. Well, let's hopefully we get there. So now the new stuff coming up video wise is we're going to be doing stuff. I'm going to show you guys some of the tooling I use, end mills, possibly some insert stuff, as well as tool holders. So Mari Tool, I've talked about them before in a video. Mari Tool USA. They've actually were nice enough to send us some tool holders, so I'm going to be trying them out. So I'm really excited about that. They're actually hydraulic tool holders, really neat. So I want to give a little explanation about them. I've been using them. I think it started yesterday, so they're really neat. Hopefully they're, they hold up to what they're supposed to, but they look pretty good, and their indicated runout's pretty good as well. Also, some of the stuff we're doing as well, there are going to be specific videos on some of the stuff we're doing for those other companies like Reversion Raceworks. Really excited about that. That's definitely coming up soon. Hopefully, it's tough. It's tough getting all these videos in order, in line, and kind of the production of them is still kind of difficult, and we're still running a shop too. So, also, some of you guys asked about doing the lathe draws. I do have them sitting over there. Actually, had to do a couple other things with the hard draws, but I have them there. We're going to get them set up. I'm going to get filming that. So look for that video specifically on setting up the lathe and running those. So you'll see that too. So that'll be another video coming up here soon of us setting up those soft draws we made in the prior video and getting them into the machine, programming it as well, and then running it, and then chucking up one of the pieces we have to do to kind of rework them and touch them up a little bit. So real pumped about that too. Again, subscribe to the channel, please, if you love this content. I'd love to keep it going. That'd be great. Comment, like, subscribe, share, all that stuff. Really helps, motivates me as well too. So this is really, really cool bringing all this stuff to you guys, and you guys get to see it, and the response is really freaking awesome. Really appreciate that. So thank you everybody for watching the video. Please check back soon. I know I said I get this video out at 2 p.m. today, a little behind. I do apologize. I'm trying to close this video off and getting it up there. So thanks again, and we'll see you on the next video.